Okay, we're working on Chapter 6, and Chapter 6's topic is loops. You should have learned some of this in Intro to Programming in terms of what a while loop is and what a for loop is, and really the concepts here are identical. It's just a matter of syntax changing. But I do plan on kind of re-emphasizing some really key things about loops because they're such an important data structure in programming. All right. So when we work with loops, and every time we step through a loop, we call it an iteration. So if you ever hear the word iterate or iteration, that's one time through a loop. And then when we reiterate, that's when we're looping, right? We're doing it again. That's where that comes from. All right, so you have a couple of different terms here. The different types of loops that you have basically fall into these categories. The while loop, the do while loop, and the for loop. And the for loop actually has a few different approaches, and we'll show that in just a moment. All right, so basically what happens with a loop is you get to a point in the program where you have a decision to make, and then based upon that decision, either you execute the code in the loop or you don't. We were just talking about that rock, paper, scissors assignment, right, and how you can run the program once through, but wouldn't it be nice to be able to play again? And where would you offer that option? At the beginning or at the end, right? In that situation, yeah, you would offer it at the end, and then you would just go back to the beginning and play the game again. And that's kind of what this diagram shows. Now, a while loop will execute based on a condition being true. So in order for the condition to actually become true, you need to preset it before the loop starts. And that's one thing about a while loop that's a little bit different than using a for loop. All right, so a while loop will keep going until whatever that value is that we're checking changes to something that will stop it. And the terminology here, I like this, definite loop, and that is one that we've set up that it's going to operate a certain number of times that we've predetermined, and it will just execute. You're going to see that with certain types of for loops, it's possible to not actually make that determination where it automatically adjusts itself, or else you write code that'll do something. Now, they have a couple little things here pointing to what they call loop control variable. Do you guys remember that terminology from Intro to Programming? All right. And that's the variable that is going to be checked in order to make the loop run. So notice the little bit of code here. You actually have a variable called val that we preset prior to the while loop that will force it to run. So val is 1, limit is 11. So 1 is less than 11, we know the loop's going to run. And then every time it does whatever it's doing, we're changing val so that hopefully at some point it will pop us out. Right? So every time we go through, we're going to add 1 to val. So the first time in, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And as soon as it's at 11, it's not going to run anymore. It's going to drop out. So what's the last number this is going to print? No, you're supposed to figure it out. That's why I put my cursor there. 10. Because if it's at 11, it doesn't run, right? And then in addition, it outputs the value before it increments. So if this statement happened to sit above the print, it would actually print 11 as the last value because it would increment on 10 up to 11 and then print it. But in this scenario, it prints the 10, then adds 1, comes up and says, nope, 11 doesn't work. Now, one problem that you might run into, and you guys are probably familiar with this terminology, is that if you don't find a way to change that variable, or your logic is wrong, you could get stuck there. We had some fun with that in class the other day, my Java 2 people, where they were stuck in a loop, and you see that console just keeps running. You got to like break out of it. Generally speaking, it says do not write intentionally unless you want to make somebody angry. It's a good way to do it. All right, so now here they're giving you a don't do it. What would happen in this scenario? What would happen with this loop? Is 4 greater than 2? Yeah. So it's going to run, right? And then when it's done, is 4 greater than 2? Is 4 greater than 2? Is it? Is it? Is it? Right? That's a great example of bad design. Because neither one of these is a variable, so they can't change, right? So there has to be a variable in this position. That's why we call it a loop control variable. And then you have to be able to change that. So, all right. If the screen sits idle for a long period of time, or the same output is displayed repeatedly, you have a loop. But check it out. To exit an infinite loop, you can hold down Control and then press C or break. Now the break key on a keyboard is the pause key, which I'm sure you guys use all the time. See where it is? It's above the page up key if you're using a traditional keyboard. It's right next to the other ones you never use. Well, print screen you might use, but scroll lock and pause you typically don't use. But that's a good thing to know, and that is if you're at a command line. If you're command line, Control C is a way to break out of most command line programs. That's a good to know thing. All right, here it says writing a definite while loop, and I think we covered this already, but it's considered good practice that, well, not considered, it must be that you set that variable coming into a while loop outside. It needs to be a variable, like we just explained. You check, and then you do whatever you're doing, and then you find a way to change that loop control variable, usually an increment or a decrement. And that's usually done, one step at a time. But there are ways to do it. If you want to subtract 10, you could subtract 10 or whatever. It doesn't really matter. All right. Here's our pitfall. Prevent the while loop from executing infinitely. All right. I think we talked about all these, so I'm not going to reiterate them. It says failing to alter the loop control variable within the loop body. So here they give an example, right? They have a variable set up, it's less than 3, but then we're not incrementing or changing it. This little piece really needs to be moved up here. Another thing that can happen is you create a loop that's got nothing going on inside of it. You got to be careful with that. And remember, when you do a while statement, you say while, you put in parentheses what you're checking, and then you got, wait, that looks okay. What's wrong with this? Oh, wait, it says the semicolon here, which I see a lot of people do. They'll write the while statement, they'll put in a semicolon, then put in the curly brackets. That's not going to work. The curly brackets are an extension of this block of code. So that's the problem there. So that's a good thing to watch for. All right, so we talked about this already too. You can increment the variable, you can decrement the variable. Java does have the plus plus and the minus minus. Remember those, right? And you can go whatever your variable is plus plus, or you can go plus plus variable. Either one works. Same with decrement. Okay, what they're recommending here too, that's kind of interesting. Start the loop control variable at 0 or 1. Why? It's easier to keep track of it, basically. Increment 1 each time. Okay, I think that's all kind of common sense. All right, so let's try to figure out what this one is doing. Writing an indefinite while loop. So I think that the point here is to try to figure out what it does. I'm going to give it a little bit of a zoom. And let's kind of examine it a little bit. All right, so we have a couple of variables here, the balance, response, and year equals 1. You got an interest rate that's hard-coded as a constant. We're going to grab a value from the keyboard. It says enter initial bank balance. So you put in a number, stores it in balance. It says, do you want to see next year's balance? Enter 1 for yes. All right, here's the scenario that you could wrap around your rock, paper, scissors if you want. So we're asking the user, well, imagine rock, paper, scissors. Do you want to play again? Right? Enter 1 for yes, or any other number for no. Grab the value, and here it says, while the response is equivalent to 1, then we're going to take the balance, add the balance plus the balance times the interest rate. Right? That's how you figure out your total balance. We're going to output it to the screen, and then year will go year plus 1. And then notice what happens again. Do you want to see the balance? So basically it's prompting again. All right. So you get the input before you start the loop, and if the person chooses to start the loop by entering 1, the loop runs. Then it does what it does, and then before it exits the loop it says, do you want to do it again? And what a person will put in is 1 again if they want the loop to run. Otherwise, they'll type in something else and they're out. So in this case, the user is actually in control of what's happening with the loop. And that approach is very common. So you prompt before you go into the loop to make the loop run. So this whole section up here is basically setting the loop control variable so we can do something. We do our work, we prompt again inside, and you'll see that these lines from here to here are identical to these. Right? All right, and then when they enter something else, you're out and done. All right. This is an important little terminology thing, and maybe you heard about it in Intro to Programming and maybe not. I think it depends on which teacher you get. I know that Alan always talks about it. I usually mention it. But it says validating data, ensuring that data falls within a specific range. And one thing that we do is we do this priming read. And what that does is it gets, as it says, it gets a value from wherever we're pulling it from prior to starting the loop. So it gets it ready to go. You guys ever operate a hand-operated water pump? You know, like before they had like sinks where you turn a faucet and it just pours out. People would, yeah, exactly. I mean, you've probably seen them in movies or something, right? Where, and that's what they do. They have a well and it would go way down, and they have this mechanism where you pump it and it creates pressure, and then the water comes up. But sometimes there's not enough pressure in the line to get the water up. So you know what you do? You pour water into the pump to create the pressure so you can pump the water up. So in order to get water out, you got to put water in. And what they call that is priming the pump. So you get it all set to go. And this is basically the computer programming equivalent of that. So input retrieve before the loop is entered. So if we were grabbing a value from somewhere, we set it up, we get the loop going, and then the loop will operate itself. Okay, same approach. All right, so this is an example of that. And notice what they're doing. He has this set up where we have this user entry. So that's going to be something we're going to be getting from the keyboard. And then we have a limit of 3. Now, I always look at this and go, why don't you just put 3 in there? But, you know, whatever. He's got it set up this way. So once again, we're going to ask the user for a value. It says, please enter an integer no higher than 3. And then you get that from the user. And if that entry is higher than the limit, what's going to happen? Right. Right. And then once again, it repeats those lines and it waits. Okay. So that's, once again, that's the approach that you can use if you want for rock, paper, scissors. And really what happens when you're writing any sort of a console program that performs a certain action and you want it to repeat what it's doing, you have to have some sort of a loop there to make it keep running, otherwise it stops. All right. It says using shortcut arithmetic operators. Have you guys seen these before? You guys know what a plus equals is? All right, that's okay if you haven't. This is another one of those, you should have learned this in Intro to Programming, and maybe you did and you kind of glossed over it and you moved on, which is fine. But the thing that I could show you is, just for example, if I'm to say, let's say I have a variable called sum, and I want to add 1 to sum and put it back in sum. I would type sum plus 1. Another way you can say that is sum plus equals 1. Those are functionally equivalent. So it just says that we're adding it back onto itself. It's the same statement. Now the interesting thing is you can do that with subtraction, multiplication, division, or modulus. I'm not sure why you would do it with modulus, but I'm sure there's a reason somewhere. The plus equals and the minus equals, those are very, very common. It's just a shorthand way to do things. Now, keep in your head here, if you find that syntax confusing, don't use it. Simple as that. If it doesn't make sense to you, just don't do anything with it. So, all right, get rid of that. The other thing that's that I was mentioning before is when you're going through a loop and you want to increment sum, let's say, or whatever our loop control variable is, and you would say, x equals x plus 1, like we were seeing in the previous loops. Instead, you could just say x plus plus and be done. And it just adds 1 to the value. All right. You can only use it with variables, unary operators. Okay, so what that means, you can only use it with one value. So I can't say x comma y plus plus. I can only say x plus plus. Right? You can only use it one at a time. And it adds 1 to the value. I have a little example here. Now this is kind of interesting because you can take that plus plus and put it in front or behind. And I'm going to tell you, this one always confuses people. In fact, it still confuses me sometimes. Generally speaking, when you put it in the loop declaration, it'll have functionally the same effect. But sometimes you're performing statements before or after it where it will have an effect. So take a look at what's happening here. Maybe it will make more sense for you. So we have value. It's set to 24. If I do a plus plus value, it becomes 25. All right. Now I set it back to 24 and then do value plus plus. The result is 25. All right. All right, great. So what's the difference? It's seemingly no difference at this point. All right. We reset it to 24 and we say value equals value plus 1. That equals 25. Value plus equals 1 equals 25. All right. So what did you just learn? How would you summarize it? Yeah, there's a few different ways where you can add 1 to a number. Which is best? The one that I would do as a go-to would be this. If I'm just adding 1, I would do variable plus plus and be done. If I'm doing something more complicated, I would probably choose a different structure. But all right, so prefix is when it's prior to the variable. Postfix is when it follows. You can also do it with the, increment, which is the positive, or decrement, which is the negative. Now, I was thinking that the last slide that we looked at kind of explained it pretty well, but I think this one will do it a little better than that. So with this, try to predict the output here and see if we can get it right. It says int my number and answer. So it just declares two variable, and my number becomes 17. Okay. System out, print line. Before incrementing, my number is, and maybe what I could do here is I can do a little box here on the side. We can type in our values. So at this point, what is my number? The first system out print line. Before incrementing, my number is 17. Oh, I suppose that would help if it was text that we could read. Okay. There we go. All right. And then we're doing answer equals plus plus my number. All right. So answer equals 18. Okay. So answer equals 18, but the next line says, after prefix increment, my number is
17.
we added to the number, right? Yes, we did. Even though we're not going my number equals my number plus plus, my number plus plus takes care of the math and the assignment. So, okay. Right, well, answer is 18 right now, and my number is 18. And then it says system out print line, and answer is, what am I typing here? I just told you what answer was. Last time we gave answer value was right here. What value did we give it? 18. All right, and then we say my number equals 17. Before incrementing my number is 17. Now answer equals my number plus plus. What's answer?
17.
Okay, wait, which one? Right here, my number is 17.
Yes.
We put it back up on the screen. Now we did a my number plus plus. So my number plus plus is 18. So answer equals 18, right? And then it says after postfix increment, my number is 18. And answer is 18. Are you guys hating me about now? Okay. Just a little, okay. Right, that's actually a kind of a fun little exercise because it kind of shows you the mechanics of it. It also shows you, and very importantly, when you do a plus plus or a minus minus or a plus plus variable or whatever, that it assigns the value to the object as it's working. Okay, so I'm actually going to delete that for future generations. All right, let's move on to the for loop. The for loop is a very important one because it has a lot of flexibility to it. I tend to see that when people get comfortable working with loops, a for loop tends to become one of the favorite kinds of loops that people use, especially if you know that you're going to be traversing a structure like an array or database entries or a file or something that has kind of a structured format to it. All right, so it says use when there's a definite number of loop iterations. So we know how many times we're going through. And the thing that's cool about a for loop, and you guys probably know this already, is the way it's declared. With a while loop, the loop control variable needs to be preset prior to checking the loop to run. The for loop builds that in. So it allows you to set a loop control variable, check it, and increment it all in one fell swoop. So it pulls the increment out of the body of the loop and takes the loop control variable declaration out of the loop. It actually kind of condenses your code as a byproduct of it. So if you take a look at the statement here, look at the while loop. This is what we were doing before. We preset the loop control variable, so we know it's going to run, so it forces it to run. It does whatever it does, and then we increment, and we go back and keep going until it's done. The for loop equivalent declares the variable directly inside the statement. That's the first part. Then it checks the condition. It's the same condition, but it does the incrementing inside the statement. So I don't have to put it into the body of the loop. It just knows that when we're done, we do whatever's here. So that's kind of cool. So you can see that it helps you condense your code a little bit. Really, we're removing 2 lines of code here, but I think it's also easier to read because you're not hunting through the body of the loop to find the increment, or you're not looking way up somewhere else in the program to find whatever's making it go. All right. It says other uses for the 3 sections of a for loop. It says initialization of more than one variable. So we can actually declare a variable that the loop's going to use to function, but we can also declare other variables that will be used inside the loop. Okay? I hope that makes sense. The other thing that you can do is you can test using ands and ors. That can get a little bit complex. You always have to check your logic. And it allows you to actually change more than a couple things. So I think that is about it there. Oh yeah, this is important. When you look at the structure of a for loop, notice that there's 2 semicolons in here, right? One is after the variable declarations, one's after the condition check. The final one does not require it, but you do not want to put one there. Why? It's the same thing we saw earlier, because if we put the semicolon there, if there's a body for the loop, it's not going to do anything. It's going to skip it. However, this little snippet of code here, notice what it does. We can actually use this to pause a program. Why? Why would this pause a program? What is this loop going to do? It doesn't have a body, but it's still going to run. It's going to go through the loop 100,000 times. Or maybe it's, 99,999 perhaps. But it's just however long the clock cycles are on the computer, it's just going to until it gets to 100,000. So what is the user doing in that time period? They're waiting. All right. So it's just a clever little way to put a pause in the program. There's also a sleep method too, but that's a separate story. So if you want your program to pause for a moment, you can do that. Right. Another type of loop is a do-while loop. The difference between a do-while loop and a while loop is that the condition check in a do-while loop is at the bottom. Functionally, that means that the stuff that's inside the loop will execute at least once. So you're forcing it to do whatever is inside there at least once. A real logical use of that, and I don't know if that's what the example is, enter your password, right? You got to do it at least once, right? If it's not right, go back, enter your password. If it's not right, enter your password. Otherwise, it just goes through. So that's one approach, or one use, really, of it. Got to be careful with this type of loop, though. in terms of logic. And I should probably state this right now, and this is a really important point, that regardless of the type of loop you use, there's always a way logically to make it work with that loop structure. It's just a matter of how you put your variables in, where you're incrementing, where you're decrementing, and what your statements are. So I can do the same thing a for loop does for the most part with a while loop or a do while. Just have to make sure your logic's okay. Now this one here says learning how and when to use a do while loop. So this one, what does he do here? Okay, this is our balance thing once again. So enter initial bank balance, it does that, gets the value, and then it just runs. It shows us our balance, shows you the output and stuff, adds one to the year, and then it asks again, do you want to see the balance? And where does it check? At the bottom. So the difference is, once again, the stuff inside will go at least once, regardless of what the user chooses. All right, can you put a loop inside a loop?
Yes.
Yes, it's called, where'd you get that information from? Yes, you should have learned that in Intro to Programming. But yes, absolutely, you can put a loop inside of a loop. And once again, you have to be really careful about your logic so you don't get stuck in there. But take a look at what this one does. It says customer equals 1. And while customer is less than or equal to 20, we'll loop, and then we'll plus plus each time through. But each time we go through this first loop, we also go through this other loop, which basically will count from 1 to 3, and then it will output a mailing label, apparently. So for 20 times, we will print 3 mailing labels. So we're printing how many mailing labels? 60. There's the pseudocode flowchart version of it. Outer loop runs, inner loop runs 3 times, again, and then it does that 20 times. Second time, 3 times, again, etc. Yeah, you want to be efficient with your creation of a loop. That's his point here. Consider the order of evaluation for short circuit operators. What's a short circuit operator? Help me, Google. Yeah, it's so hard. You guys have computers sitting in front of you. I don't know the answer. Oh, there's the answer. And Alana, as soon as you find it, you let us know. You should type Java, or what is a short circuit operator in Java? Yeah? It's still in, so everything's in Stack Overflow. Trying to see how fast you guys find information. So you know what happens when you get a job as a programmer? You have all sorts of stuff you look up all day long that you try to figure out what it is. So I want you to be in that mindset. It's absolutely okay to Google stuff if you don't know it. Over time, you will get to know it. But until you do, and I can just tell you from my experiences, there's some stuff that I never always remember. You know the basics, but you don't necessarily know the others. Now, while you guys are still looking that up, it says another way to improve loop performance is to make comparisons to 0. Why do you think that is? How about 0, when you're storing it in memory, has a much smaller footprint than if I was comparing it to like 1 million, that's going to take up more memory. It's the ands or ors. Those are short circuit operators. Okay. Yeah, so it says, consider the order of evaluation for short circuit operators. And really what they mean by that is something like this, right? If I said, let's make this a color that we can see. So let's say I wrote a little program, right? And I said that x equals 2, right? All right, fine, it's an int. And let's make another int and say y equals, please ignore the case, okay. And then we're going to run, let's say, a while loop or a for loop, and let's just do while because it's probably easiest for this. And then you're going to put in a statement where I might say something like, while x equal 2, how do you do an or? Yeah, or is the pipes. And how do you do an and? Yeah, it's good to know. Okay. I didn't. Yeah, I didn't. I didn't name the stuff, but yeah, I know what you mean. Somebody was telling me the other day that the asterisk is trademarked. Like if you're going to use an asterisk, like in the logo or something, and I don't know how true that is, but that they insisted it was true. Yeah. I would think that the guy that invented email would copyright the @ sign. All right, so we know that these both evaluate to true, right? Because we can see it. But in order for this to work, so if I was doing an and statement, both sides need to be true for the loop to run, right? But what happens in the situation where I do an or? Yeah, one or the other has to be right. And a short circuit basically is, it comes in here, remember, only one has to be right. It goes, this one's right, I'm done. Doesn't even check the second part. That's a short circuit. So it doesn't check the second one unless it needs to do it. Okay? Maybe I'll actually leave that there. All right, let's move on. We're almost done. All right, so here it says, don't use unnecessary operations or statements within a loop's tested expression or within the loop body. So it says avoid x is less than a plus b. What it's telling you to do is do the math before the loop and then check it in its simpler form inside the statement. So if you're finding yourself writing really complex formulas and statements and methods inside of a while, then that's where you should start breaking it down a little bit and separating it. You'll also find that's just, easier to, walk through the logic. So here they talk about short circuit again. It says each part of an and or an or is evaluated only as much as necessary to determine the value of the expression. Of course, ands, all things have to be true, or only one needs to be true. Why is 0 better? It's easier because it doesn't hold as much. What's a do nothing loop? That's absolutely ridiculous. All right, so here they're doing the comparison to 0 example. I'm not too concerned about focusing on that, but let's take a look at this a little bit. Sometimes you'll find a way where you can actually combine loops. So if you have like operations that are this has to loop and then this has to loop to get it done. If you can find a way to do them together, it will save you actually processing power. And as it indicates, that's not always appropriate, but if you can do it, you should. And let's take a look at this little guide. It says using prefix rather than postfix for incrementing. All right, so the prefix, it says when the method receives a reference to x, the value is increased and the increased value is returned. Now notice it says when the method receives a reference to x, a copy of the value is made and stored. Difference, right? A little bit of a difference. The value is incremented as indicated by the reference. The copy is returned. So extra time spent copying causes postfix to take longer, because it's creating, every time you do it, it's creating a copy, and then we're sending the copy back. So it takes more memory and it takes more action, where with the first one it just changes. So if you're thinking about performance, this is a better approach. All right, I'm not going to worry about the example here. You guys can read that on your own. And then he's got his do-its and don't-do-its, and that's basically the chapter. So we're going to end the video here, and then we'll take a short break.